Here I have a SAT math question. Okay, let's go with the information. There is a scatter plot given over here. Okay, now let's go with the information here. The scatter plot above shows the relationship between the speed of the driver and the amount of the fine in dollars for 15 speeding tickets issued by a local police department. The line of best fit is also shown. Which of the following is the best interpretation of the slope of the line of best fit in the context of this problem? Okay, so here based on the information we have, there is a scatter plot we have over here. So we have to interpret the slope of the line of best fit that we have over here. Usually when we have a line on an XY plane, we can find the formula that is rise over run to get the slope. That is slope equals to rise over run. Okay, so this rise gives how the values on the vertical axis change, and this run gives how the values on the horizontal axis change. So here on the vertical axis we have fine in dollars, and on the horizontal axis we have speed in miles per hour. Okay, so now the slope of the line of best fit gives a fine over speed. And also let's go to the scatter plot over here. So what if I increase the speed over the speed limit? So when I increase the speed over the speed limit, what's happening in the line of best fit? Is it going up or is it going down? Clearly it's going up. So that means the fine increases. So whenever I increase the speed over the speed limit, so what's happening in fine? The fine increases in dollars. So the slope, the best interpretation of the slope over here is, so the increase in fine in dollars. So when the speed increases for every mile per hour over the speed limit. Okay, now let's keep this stuff in our mind, and we can go over the options one by one. Okay, now let's go to the first option, that is option A. The estimated increase in the speed of the driver in miles per hour for every $10 increase in the fine. Actually, logically, this is incorrect, option A, because according to our interpretation of the slope over here, there is a fine over speed. That means estimated increase in fine in dollars with respect to the increase in speed in miles per hour for the over the speed limit. So, but option A says how the speed changes with respect to the fine, but that's logically incorrect. So we will never calculate the speed with respect to the fine. So we can reject option A. Okay, now let's go to option B. The estimated fine increase in dollars for every 10 miles per hour over the speed limit. Okay, I think the option B says something correct logically, because already we have interpreted the slope over here. That is the estimated increase in fine in dollars with respect to the increase in speed in miles per hour over the speed limit. But here the tricky thing is every 10 miles per hour. So, and also when the students look at the numbers on the horizontal axis, they may feel this is correct. Actually, we space the numbers over here according to our convenience, and also it depends on the size of the numbers. So like here the numbers are spaced on the horizontal axis with 10 units gap, 50 to 40 to 50, 50 to 60. Actually, we will do this one according to our convenience. So for example, if the numbers are too big, sometimes we'll space the numbers with 100 units gap, and sometimes we'll do it with 1000 units gap. So it doesn't matter. So how the numbers are spaced on the horizontal axis, it will not come into the matter when we find the slope of the line of best fit. So we cannot consider that, and also there is a unit given for speed, that is miles per hour. It's not like 10 miles per hour. It's logically cannot be accepted. So we can reject option B as well. So like whatever stuff we have speed in miles per hour, that is for every mile per hour only we have to calculate the speed. Since the numbers are spaced with 10 units gap, we cannot calculate the speed for every 10 miles per hour. That is incorrect. Okay, now let's go to option C. The estimated increase in the speed of the driver in miles per hour for every $1 increase in the fine. So this is also logically incorrect, because because option C says that the interpretation of the slope is how the speed increases with respect to the fine. So like in case if the fine is too low, like we can increase our speed. That's logically incorrect. So option C is also incorrect according to that logical mistake. So it's similar to option A. Okay, now let's go to option D. The estimated fine increase in dollars for every miles per hour over the speed limit. So this is perfectly correct, because already we have interpreted the slope over here. So how the fine increase in dollars with respect to the increase in speed in miles per hour over the speed limit. So as I said earlier, like the space of the numbers will never matter when we calculate the slope. So here in this scatter plot, the numbers are spaced with 10 units on both the vertical axis and horizontal axis. But sometimes even it will be spaced with 100 units. It depends on the size of the number. It will never matter. And also we can consider the unit of the speed, that is miles per hour. So speed, the increase in speed has to be taken for every mile per hour. So when you increase the speed of the vehicle every mile per hour over the speed limit, the fine will automatically increase in dollars. That's exactly given in option D. So this is the best interpretation of the slope. So the correct answer choice for this question is option D.